So hi all, today we will see this question, print all longest common subsequences. So what is this question? You are given two strings S and T. Now your task is to print all longest common subsequences in lexicographical order. So first of all, let us see what is a subsequence. So if I have a string like A, B, C, D, then what are the possible substrings for this? The substrings could be, I'm not writing all the substrings, so let us generate random substrings. So this could be AB, BC, CD, BCD, ABC, like this. That is, it has to be continuous. And what are the subsequences that we can generate? It could be AC, it could be BD, it could be ACD, like it might or might not be continuous. And in this question, we have to generate the subsequence, that is might or might not be continuous. But unlike this, we are not given a one string. We are given two strings. And let the first string is A, B, A, and the second string is K. So these are the two strings that are given in question. And we have to find the longest common subsequences. So let us see what are the common subsequences among these two. Some possible common subsequences. So see, if I start from this position and I'm comparing, so I know this and this are same. So one possible could be this A, 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 okay. And now we see this B and this B same. So the one possible could be AB. Now this A and this A same. So another possible could be ABA. Then this A same. Then another possible could be ABAA. Okay. Now again, if we start, so now if we start with some another character, like we start with A, but what if I start with B? So this B and this B matched, then this A matched, then this A matched, and then this A and this A match. So another possibility could be this also. And what if I start again with some another character, like I take this A and this A, then I'm taking this A and this A, then I'm taking this A and this A, and then I'm taking this A and this A. So among all these common subsequences, which are the longest one? This, this, this. And we simply need to print this. But while printing, we have a condition that we want to print them in lexicographical order. So first we'll print this, which is A, then we'll print this AB, and then this B. Okay. So see, the procedure for solving the problem is quite clear in this, like what we need to do. First, we need to calculate the length of the longest common subsequence. Here I know the length of the longest common subsequence is 4. And now I can generate all the common subsequences, and whenever I reach this length, then I know that I have reached the length of my longest common subsequence, and now I can simply add this to my resultant vector. Okay, so the first step is to calculate length, and the second step is to print, which is to store that in a resultant vector. So while calculating the length, as you can see clearly here, what we did was, if the characters are matching, then our length gets updated by 1. And if a character is not matching, then what we are doing? We are trying with this subsequence also, and we are trying with this subsequence also. And we got the answer from both of these. Like after this, I tried B also, and then I tried A also. Okay. So what we will do, for the finding the length of the longest common subsequence, suppose I have a string like A, B, C and another string like B, A, C. Let it be A, A, C. Okay. So if my current character of I and my current character of S and current character of T are matching, then I know that for sure this will be the part of my longest common subsequence. And since in this part we are only concerned with the length, so if the characters are matching, I can simply increment my length, and now I will check for these subsequences. That is, in this string now I will find the longest common subsequence. And whenever I found a character same as the length, then I will simply increment my count and recursively call for the next character. But what if my characters are not matching, that is BAC and ABC? See, one thing is for sure, that is now I don't have to increment my pointer because I know that these are not matching, so it definitely is not a part of my longest common subsequence. But if I do like this, like now I will check this and this. So these characters will get wasted because there is a possibility that this character will be matched with some another next character of this string, or this character will be matched with some next characters of S string. So what I will do, I will try both of these approaches. That one once I will make sure that I'm storing the B, and I will recursively call for this string, and this will remain the same. And one time I will do that I am leaving the B unchanged and I am moving A ahead. Okay, that is what we are doing. In first approach, what we are doing, we are just incrementing our I pointer, and in next we are incrementing our J pointer. And since I need to find the longest one, so whichever will be the maximum will be my answer. So briefing you about this, what we will be doing, we will be given two strings S and T. If the current character of S and the current character of T is matched, then we will increment our pointer, and now we will recursively call for the next characters of both the strings. But what if the current characters are not matched? If the current characters are not matched, then we have the two possibility that we can make S unchanged and we can move T one pointer ahead, and the another possibility is we can make T unchanged and we will make S one pointer ahead. That is, now we will compare this T with this remaining S, and in this we will compare this S with this remaining T, and whichever will be the maximum will be my answer. Now for this recursion, what would be the base condition? See, if my S substring has ended, I am at this position, but my T is at some midway, then is there any possibility that I will be able to find any common subsequences among the two? Because the string S has already ended, so it has no character in it. So no character of this will be matching with this string's character. So if any of the string has reached its end, S or T, then what we can do, we can simply return 0 because there is no possibility of matching the characters now. So this was about the finding the longest length of the longest common subsequence. So let us see the code what we did, and also to optimize it, we will make one DP. We will use memoization. For every current positions in S and T, I will store the longest common subsequence till that point in this DP. And whenever I'll be needing this, I can simply fetch that in constant time because this will be needed in printing task also. So what I did, the base condition was if any, so basically this string has parameters like string S, the first string T, the second string, position 1, that is the starting position for the string S, and position 2, the starting position for the string T, and initializing with both of these as zeros. So if any of the string has reached its end, so we will simply return 0 as there is no longest common subsequence that can be formed now. And if we have already calculated the longest common subsequences for these position characters, then we'll simply return it from here, we'll not calculate it further. Now, if they're not equal and we want to make the recursive call, so we have two steps. First, if the current character of S matches with the T, then what I do, I simply update my pointer and call the recursive function with moving ahead both the pointers. And if they are not equal, then what I do, in one way I just increment the first pointer, and in another I just increment the second pointer, and whichever is the maximum will be my answer. So this was all about calculating the length for the longest common subsequences. Now our task is to print all the longest common subsequences. So as we see earlier, what we did while printing was, see, first of all, the thing is that we want to print them in the lexicographical order. So what we can do, from A to Z, for every character we will check in the first string if we have this character. And if this character is found in the first string, now we will check for this character in the second string. And if this character is present in both of these strings, then I can say that this will be part of my longest common subsequence. So I will add this current character to my current string. Okay. Basically, I will need two pointers. One to store the current LCS. Basically, whatever the characters that I am getting, I will store in this. And another pointer that I will read is current LCS length. That is, what is the length of my current LCS. So if my current LCS length matches with my longest common subsequence length, then I know that I have found one subsequence, and now I can simply add this to my resultant vector. Okay, so if the character in both the strings match, so I will add this character to my current string. And now initially my current string was empty, and now since I found this character, suppose the character that I matched in both of the strings was A, so now my current is A. Then I will recursively call this print function by sending current as A. So like we did in the test case, that we have a string A, B, A, B, A, B, A, C, A. Suppose I'm matching A with this A. So next time when I was matching this A with A, I was appending this A to my current string. And then I match this A with this A, and I'm appending this A to my current string. So what I'm doing, whenever I'm getting a character that is present in both of the string, I'm simply appending that character into my current string. And when my current string length becomes the length of the longest common subsequence, I simply add that string to my resultant vector. So that was all we did earlier, and we will do the same now. So let us see the code for it, and I will try run this print approach for the test case. So see what we did. Basically, base condition, we know that if the current LCS length is same as LCS length, then I can simply add this current string to my resultant vector and I can simply return. But what if the subsequence that I am forming is not a part of a longest common subsequence? So how I will be able to know that? Definitely one of my pointer will reach its end. So if any of my pointer has reached its end, that is we can simply return because this is not a part of our longest common subsequence. And now for lexicographical order, we are checking for all the characters from A to Z. And now we are checking if this character is present in the first string. And if it is present in the first string, we are checking if this character is also present in the second string. And if yes, this character is present in the second string, this length condition I will explain you while I will dry run. So if this character is present in both of the string, I can simply add this character to my current character, and now my new current string will become this string, and I will simply call recursion. I will simply recursively call this function again, and now my current string has been updated with the new current, that is with updation of the current character, and the pointers will move ahead. And since I have found one character here, so I can update the current LCS length by 1. And what is this flag variable doing? Since we don't need repetitions. If there are repetitions, we have to avoid them. So for that, I am taking this flag pointer. So let's just dry run this on some test case. So we can dry run this algorithm on some test case. The identification is good. Let me just make it some proper way. So it seems better now. Okay. So now let's dry run this. Yes. Okay. So let's just dry run this. So let us take the second test case. So see, I have the S string as AAA and T string as A. And what all these helper function we're accepting as a parameters are the string S, T. Then we have the current string, and the current string is currently empty. Now we have position 1, position 2, that is starting position for S and T. And now we have current LCS length, which is also 0. Now what I am doing is the current LCS length is same as LCS length, and what is the LCS length for this subsequence? This is 1 because only this character is matching. Okay. So is the length same? No, the current length is 0 and the LCS length is 1. So they are not matching. Now is any of them has reached its end? No, we are at the starting position. Now we are at this point. Our CH is at A. Now our F has become false, that is अभी हमने इसे visit नहीं किया. Now we will start our iteration from the first string and we will find if this character is present. So what is the S of I? What is I currently? I is currently 0. And what is S of 0? This is A. Is S of 0 equals to CH? Yes. So I will run this nested loop where J is now position 2, which is 0. And now we will see if T of 0, that is A, same as CH, A, yes. And now we will see what is this length function doing. See, if we have found the character in both of the strings, then what we will see? See, we are finding the longest common subsequences from this point. Suppose the string is S and T, and now my I and J has become 0, 0. They are still 0, 0. So we have to compare the length of these two. That is, we have to compare the longest common subsequence length from this I and J pointers with the remaining length of my longest common subsequence. That is, what was my longest common subsequence length? This was 1. And what is the current length? This is 0, which becomes 1. And now I am calling this LCS function again by sending this I and J the starting position. And now what is the longest common subsequence? This is 1. So yes, this is same. So only then we will append this into a string. That is, we are checking if the remaining length of the longest common subsequence is same as the remaining length for this subsequences. That is, by sending I and J the starting position. So what I will do, I will simply update my current string with this character, that I will append empty. I will add a character to my empty string, and now my string has become A. And now I will recursively call this function where my position 1 has been updated by 1, position 2 has been updated by 1, and current LCS length has been updated by 1. Now if I see if my current length of LCS same as LCS length, yes, so that is, I have found a subsequence which is of longest length. So I am simply adding this back to my resultant vector. So adding this string, which is new current A, to my resultant vector. Now my resultant vector has this A string, and now I am returning. Now after the returning, where the control goes back to the recursion, to the next statement of the recursive call, that is here. That is, now my F will become true. So now my F has become true. Now I am at this point and my F has become true, so I am simply breaking the condition. So when I am just going out of this loop, now I have terminated this J loop. And now after the J loop, what I will do, I will just update my I. Now initially my I was 0, now my I will become 1. And now when my I will become 1 and I am checking if the current character of S is same as the CH, yes, this is same. So what I am doing, I am traversing the J loop also. Now when I am traversing J loop, now I am at the position 1, which is less than T dot size, no. So I will not enter to this J loop. And when I am not entering this J loop, I will simply enter to this condition. If flag is true, so yes. because before only we just made the flag as true. And now if we have made the flag as true, we can simply break the condition by, because we have checked the character from starting with A and there is no more possibility. And now we'll simply update our characters and simply check for all of these, but none of these character will match because no more character other than A is present in the string S. So this was the resultant vector. So that was all about this problem. We have done this, we have seen how to calculate the length and how to print this. So if you have any doubt, feel free to comment. Thank you.